Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. It's an honor to be a presenter at the third annual Engineering and Vocational Education Conference 2021. Let me introduce myself. My name is Bugy Pagesty as the first order from Building Engineering Education Program Study at 11 Maret University. I will explain my paper. The title is Horizontal Control Framework using Closed Polygon Method as the basis of UNS PABELAN Campus Mapping. Introduction 1. Land surveying. Land surveying is a branch of geodesy that focuses on how to measure on the surface of the earth as well as below it in order to identify the relative or absolute position of points on the ground surface for purposes such as mapping and determining the relative position of an area. 2. Situation map. A situation map is one of the large-scale results of the process of land measuring and topographic mapping of the Earth's surface. For detailed mapping, a situation map measurement is a measurement used to create a map that may depict field circumstance, including both horizontal XY coordinates and height or elevation Z position. 3. Control points or framework. Start of land surveying carried out in the situation mapping work is the creation of basic mapping points. The basic framework is a number of points whose coordinates are known in a particular system that has a function as a binder and a new size controller. Given its function, the basic frame points must be placed evenly through the area to the map with a certain density. For UNS PABELAN campus, the UNS PABELAN campus is the 11 Maret University campus mirroring in vocational engineering education and is the fifth branch campus of 11 Maret University located at Jalan Ahmad Yani, Makahmanji, Kartasura, Sukoharjo Regency, Central Java. According to the lecturer in land measurement, Mr. Dr. Andes Waluyo MPD, as an expert of land surveyor, UNS PABELAN campus is included in closed land which does not yet have an accurate and detailed situation map. Moreover, UNS PABELAN campus has several new buildings, so it is necessary to create an accurate horizontal control framework as the basis for mapping the situation and details of the UNS PABELAN campus. Materials and method are tool and materials. The tools name are first total session, and then stative, saddle, prism, yellow compass, rollmeter, umbrella. And the materials are first wooden peg, and then porcelain, customer shells and tools, hammer, thumbtack, stationery, felt data form, field sketch, and laptops. This research was carried out in stage in the period January 2021 until June 2021. It include the stage of preparation, benchmarkings, land surveying, and data analysis, as well as description of the horizontal control framework. The study used an experimental method where the experiment used is direct land surveying on a closed land. The closed land is the UNS PABELAN campus, which does not have an accurate situation map. Data analysis. The data from the survey work will then be analyzed using the closed polygon measurement method, which is described as follows. A closed polygon is a closed shape or ring so that it forms a polygon or N. n is the number of points of the polygon. The geometric condition for a closed polygon are terms of measuring are sigma beta equals n minus 2 180 degrees, and then sigma beta equals n plus 2 180 degrees. For equation 1 is a calculation using interior angles. Equation 2 for calculation using exterior angles. Terms of abscissa and ordinate are sigma d sin alpha equals 0, and then sigma d cos alpha equals 0. The principle of calculating the definitive coordinates of xy of polygon points follows. Xi equals xi until 1 plus di sin alpha accent I plus fxi, and then yi equals yi until 1 plus di cos alpha accent I plus fyi. Result and discussion. The measurement of the horizontal contour framework at the UNS PABELAN campus produced 44 controls point P1 to P44, which are tied to the BM point of the UNS PABELAN campus, which is sort of building a UNS PABELAN campus. The coordinates of BM we can see on the screen were obtained from previous measurements using the GPS method with the geodetic GPS tools is RTK CHCNAVI 50 in 2018. The measurements were made in collaboration with PT Asaba. In this measurement, the researcher used a total station with an angle accuracy of 5 seconds. So for the angle error tolerance, f beta in the horizontal contour framework measurement, it's we can see on the screen. So the angular error in the measurement should not be more than 33.1612 seconds. If it exceeds, then you have to remeasure. From the measurement results of the horizontal contour framework, it can be seen the resulting angle correction meets the angle error tolerance according to the closed polygon method. The total number of external angles measured is we can see on the screen. While the calculation of the external angles that should be used for the measurement of whatever control points is follow. External angle calculation equals 8,280 degrees. So the angular error generated in this measurement is f beta equals 3,530 seconds. Since the angular error tolerance for this measurement is 33.162 seconds, it means that the angular correction is this measurement exceeds the existing angular error tolerance, or more than k in. So our measurement must be carried out. The researchers observe which point must be remeasured so that there are no more errors in measurement. After doing the remeasurement, the researchers recalculated the number of external angles which were calculated in this remeasurement, resulting in, we can see on the screen. Then it's necessary to calculate the angle correction with the remeasurement data so as to produce f beta equals 9.999 seconds. So the angle correction for this remeasurement is 9.999 seconds with an angle error tolerance of 333.1662 seconds. So that less than kn. Then proceed to the calculation of the correction to each control point, namely f beta per n, where n is the number of control points. That the angle correction of each point is 0.2273 seconds. After being corrected, proceed to the azimuth calculation by knowing the azimuth of point P1, which is, you can see on the screen, it can be seen the azimuth of each counterpoint with the formula in the equation 11, 12, and 13. From the result above, the coordinates are at the starting point P1 and D and P1 are different. Therefore, there is an abscissa correction Fx of 1.1031 meters and an ordinate correction Fy of 0.2023 meters. With these results can be generated. TL equals 0.0014 and FL equals 1.215. After obtaining the definitive XY coordinates from this measurement, the researcher continued to create a horizontal control frame drawing based on existing and accurate data using AutoCAD application. Conclusion. This research produced 44 control points as a horizontal framework using the closed polygon method, stating that the resulting horizontal control framework meets the requirements of angle correction, abscissa correction, ordinate correction, so that this horizontal control framework can be said to be accurate or can be used for further research, namely the measurement of the mapping of the UNS PABELAN campus. And this is the final product of my research. We can see on the screen. This is the horizontal control framework at the UNS campus PABELAN mapping. Okay, thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.